In this lesson, we will examine some tips for tackling data sufficiency questions related to geometry. The first tip is, do not estimate lengths and angles. The figures in data sufficiency questions are often intentionally drawn out of scale to mislead test takers. For example, in this figure here, we cannot draw any conclusions about any of the angles or lengths of the sides. Although this certainly appears to be an equilateral triangle, it could very well be a right triangle. So to solve a geometry question, we must apply the formulas and rules related to the figures at hand. The next tip is, to find one length, we must be given at least one other length. Take this example. Here, the target question asks us to determine the length of side AD. Now, if a data sufficiency question asks us to determine a length or an angle, it is often the case that a statement will be sufficient if it locks the shape into having one particular angle or length. In other words, a statement will be sufficient if it forces the shape into having just one angle or length. Now, in this question, we want to find the length of side AD. So we want to determine whether the statements force this side into having just one length. Statement 1 tells us that x is 30, so this angle is 30 degrees. Does this information force side AD into having only one length? No. Our rule tells us that to find one length, we must have at least one other length. Here's why. We can take the figure shown here and make it larger while still maintaining the angles. So the angles in the figure remain the same, but the length of side AD changes. Since statement 1 does not force side AD into having just one length, statement 1 is insufficient. Now statement 2 does not provide any lengths either. It tells us that sides AD and DC have the same length, but we are not told what that length is. As such, we can take our diagram and make it larger and smaller while still maintaining equal lengths for sides AD and DC. Since statement 2 does not force side AD into having just one length, it is not sufficient. Now, even when we combine the two statements, we see that we still do not know any of the lengths in the diagram. This means there is no way that we can determine the length of side AD. So statements 1 and 2 combined are not sufficient, which means the answer is E. The next tip here is sketch the figure and add information to the diagram. Since the geometric figure will appear on a computer screen, it's a good idea to sketch the figure on your scrap paper. This will allow you to add any extra information that you deduce about the figure. Now in this example, we are told that sides AE and EC are equal. So once we sketch the figure on our scrap paper, we can add some notation to show that these two sides have equal length. Now since these two lengths are equal, we can deduce that this is an isosceles triangle, which means this angle and this angle are equal. Now the target question asks us to determine the length of side AB, so we'll highlight this. Okay, we're now ready for statement 1, which tells us that side AC has length 10. So we'll add this to our diagram. Now does this information force side AB into having just one length? Well, one way to answer this question is to mentally grab points and lines on the diagram and try to move them without breaking any of the restrictions you have been given. In other words, we want to see if we can move parts of this diagram without breaking the restrictions that tell us that sides AE and EC are equal, that we have 4 right angles, and so on. Now here's what I mean. I'm going to mentally grab this side here and push it down. Notice that we can do this without disrupting the information we have been given. Side AC still has length 10. We still have 4 right angles, and sides AE and EC are still equal. So this new diagram still retains the given conditions, however, side AB is now a different length. Now notice that we can take the top side here and pull it up to get a taller diagram. Once again, the new diagram still retains the given conditions, but now side AB is another length. This tells us that statement 1 does not force side AB into having just one length, so it is not sufficient. Now, before we examine statement 2, we must remove the information from statement 1. Now, statement 2 tells us that x is 30, so we'll add this to our diagram. Now, does this information force side AB into having just one length? Well, we want to find the length of side AB, and at the moment we are given no lengths in this diagram. So applying the rule from earlier, we know that statement 2 is not sufficient. Now, what about statements 1 and 2 combined? Well, first we'll add all of the information to our diagram. Do we now have enough information to force side AB into having just one length? Well, let's see. To do this, we're going to reconstruct our diagram using the given information. So first we have side AC with length 10. Now at points A and C, we'll add the beginning of two sides, both drawn at 30-degree angles to side AC. Now these two sides are fixed since there is only one way to draw them at 30-degree angles to side AC. So once these two angles are established, we can see that the destinies of the two sides are fixed. There is only one possible place where those two sides can meet, and that meeting place is at point E. So given the information in statements 1 and 2, point E is forced to be in this exact location. Now at this point, we can recreate the original diagram by extending a rectangle up from points A and C. Now the top of this rectangle must intersect point E as in the original diagram, so there is only one way to accomplish this. So we can see that statements 1 and 2 combined force the diagram into only one possible shape. As such, side AB is forced into having only one length. Now we don't really care about what that length is. All we care about is that the two statements combined force side AB into having exactly one length, which means the statements together are sufficient, and the answer is C. So in this lesson, we learned some tips for tackling data sufficiency questions involving geometric shapes. First, do not estimate lengths and angles. Second, to find one length, you must be given at least one other length. Third, sketch the diagram on your scrap paper and add information to it. And fourth, mentally grab points and lines on the diagram and try to move them without breaking any of the restrictions you have been given.